Hello everyone. So today we would be discussing about the types of plate boundaries, and those are convergent, divergent and transform plate boundaries. Starting with the convergent plate boundaries. What are convergent plate boundaries? Convergent plate boundaries are those plate boundaries where the two tectonic plates or the two lithospheric plates starts moving towards each other. They starts moving towards each other. If it is convergent in nature, they would be start moving towards each other. And there are various type of convergent plate boundaries. One of them is Oceanic Continental. What happens in Oceanic Continental is there is one plate that is oceanic in nature, another plate would be continental. So here it is, this one is oceanic and this one is continental. So the oceanic plate, as we already know from the previous video, that the oceanic plate is more dense and the continental plate is less dense in nature. So the plate which is more dense, when both the plate are colliding, and then the plate which is more dense would start to go down, it will sink, and the one with the lesser density would be above. So the oceanic plate with less density, it starts to move down and it gets hotter when it reaches near the mantle. As the magma which is present in the mantle is hotter compared to the minerals which are in the crust of the earth, so the minerals which are in the oceanic crust also get hotter, but the difference in the density of the oceanic crust and the mantle minerals is very high. That's why these minerals of the crust rises up further towards the crust. Due to the density difference in the uh, minerals of the oceanic crust and the minerals of the magma, the oceanic crust minerals would start to rise up, and it will rise up as volcanic eruption and it's come onto the surface as lava. This is how the oceanic continental convergence process occurs. Mainly in the beginning, the plates start to collide. The one with higher density would go down, but due to the density difference between the crust minerals and the mantle minerals, it starts to rise above, and it rises above, and lava would come out. Example of this is Andes mountain range. So we have this South American plate. The South American plate, this one is South American plate, and this South American plate is continental plate. The other one is Nazca plate. Nazca plate is oceanic in nature. So both of these plate starts colliding, converging into each other. When they start to converge, Nazca plate is oceanic in nature. It has more density, so it starts to go down. And when it starts to go down, it gets sink, and further it rises over on here as some eruptions, and here the Andes mountains formed. But when this Nazca oceanic plate is going down, it lead to the formation of some dip. It formed as a trench over here. This long surface is formed as a trench. Why this is formed as a trench? Because this oceanic plate has gone down. This has gone down on this reason. So as it has gone down, this region has trench parallel to the Andes range. This is how Andes mountains formed. Oceanic continental convergence. Coming over to the next. The next one is oceanic convergence. So if we are taking the example when both the plates are oceanic and they are also converging in this way, but the thing is now both of the plate have high density, but the one which is older has more density. So the older one would have more density. So the one with more density now starts to go down. So the one with more density, so let's say this is older and this is with more density, so it will start to go down, but the one with a lesser density would be above. It is the oceanic crust is cooler when it is in the upper surface of the earth, but when it will go down, it get heated by the magma present over there. It get heated by the magma present in the mantle. So due to the density difference, it rises up. Due to the formation of lava here, we get these volcanic eruptions. Overall, this process of colliding of the plates, denser would go down by the process known as subduction, but later on density different, it rises up and hence lava comes out. Example is of the how the Japan formed. So this Pacific plate, oceanic plate, this Octos plate, oceanic plate. Here also we have Philippines Sea plate. So Philippines Sea plate also goes down here. So Philippines Sea plate also has gone down. It means it also has been subducted here. Pacific plate also subducted here. All the plates subducted from this side, it also subducted from this side. So the plate which is older got subducted and lead to the formation of Japan. And that's why as they have subducted here, we have the formation of trench in this region. So this trench has been formed, this trench in this region has been formed because of the subduction taken place. If the plate has subducted, it lead to the formation of trench on one side and these uh, higher range regions in this region. Not very high regions as mountains, but much higher than the normal sea level. So this got erupted and this just parallel to it we will have some trench. So this is the trench. This is how Japan formed by the convergent plate boundary. So in case of continental, when they starts to come towards each other, when these plate starts to collide, there is very less density difference between both of these plates. That's why subduction takes place here also, but not as much as in the previous two cases. But here these two plates starts to get collide, and by the process of faulting and folding, it leads to the formation of mountains. We can take the example of Himalayas here, which is formed by the process of folding and faulting. This is the Indian plate which is moving here, Eurasian plate here. Both of these plates are continental in nature. When the density difference is very lesser, these plates would collide and gets folded up. This would get folded up this way, and leads to the formation of Himalayas. This is a very classic example of continental convergence. This is how Himalaya range got formed. Moving ahead, one question is here. So in this question, there are two statements. We need to figure out that which one of them is correct and which is not correct. First is convergent boundaries of the plates do not exist between two oceanic plates. As we have discussed in previous slides, that convergent boundaries also exist between two oceanic plates. We have discussed in the example of Japan that two oceanic plates lead to the formation of Japan. So this statement is wrong. The second statement is rotation of the earth has effect on separate blocks of plate portions. So let's take an example of a Pacific plate. So if Pacific plate has some impact over, let's say, in the process of formation of Japan, that portion of plate is active, but might be some portion of Pacific plate near to North American plate which is not active. So it can be the case that some parts of one plate is active at some time, but some place, but not active at another place. Because the plates are very large in size, they may be active in some portion at some time and in other portion at some other time. So this statement is correct, and this statement is not correct as we have seen in our previous slides. Moving ahead, the next type is divergent plate boundaries. So in case of divergent plate boundaries, what happens that the tectonic plates starts to move away from each other. The plates start to move away from each other. So let's say we have oceanic plate, and let's say magma rises from the mantle of the earth, and it is coming above due to the convection cycles which are formed, as we have discussed before in our video, that the convection cycles work here, convection current cycle. So that the magma rises up, starts to move here as per its cycle, but due to the very strong force working here, and this force let the lithospheric this lithospheric plate also move in the direction of this convection current. That's why the upper crust also see some divergence. This divergence is because of the convection current cycle which started from the mantle of the earth, and it lets the surface crust also move in that direction, and due to which we can see that the land breaks down. If it is oceanic in nature, the example is mid-Atlantic region island of Iceland. This is how the land got broken there due to the movement of magma from the earth. Iceland is in the mid of that North American plate and Eurasian plate. Uh, so we can see that much high break is there. This is our mid Atlantic ridge. So this is how this break has taken place due to the divergence process. Moving ahead, the next type is continental. Same process happens, same divergence happens in case of continents also. So the magma rises up, lets the upper crust of the lithospheric plate moves along with it, and it moves this way and leads to the formation of cracks in the continents. And that space will be filled by some rivers, lakes, other things on the surface crust, but it has been created by the process of this convection current. Example is East African Rift Valley. Very classic example is East African Rift Valley. The uh, African continent, this is the continent, it has been divided by the divergence which we can see here. So this is the continent, and you can see that this divergence is created, this is created by the divergence forces acting here. This Red Sea, which we know as Red Sea, has also been formed by this process, divergence process in this region. So it will take a very long time, say million of years, but this part will get divided from the African continent after that time, after this divergence process got completed in this region. Next one is transform plate boundaries. So in case of transform plate boundaries, we have the two plate slide over each other. They do not uh, collide. They do not move away from each other. They just slide past over each other. It is passing over there. It is passing over here. No collision this way, neither move divergence. Very San Andreas fault is a very famous example of this a transform boundary. So this plate is Pacific plate, and this plate is moving northward, and the other one is North American plate, which is moving slide past this plate. So this region has transform plate boundary. This region is very famous for transform plate boundary. San Andreas Fault, USA. I hope you understand the video well. Thank you for watching.